Hello and welcome back to a new video here on the Ludwig Fussel channel. Today we're gonna explore on with our virtual inheritance and writing base classes and extending classes and working with cats and dogs and being naughty to dogs. So yeah, that's where we left off last time. We created a cat and a dog and it was called a sad story about the dog, and at the end the dog died, which was sad, but I don't know what I really thought of doing that, because it's probably gonna offend people, but yeah. Again, it's a sad story, but that was like the idea here. Alright, so now that we have talked about these like structures of classes, hierarchy, and putting this all together, I want to talk about a very specific super class. I want to talk about an interface. Now, in languages like Java, a interface is distinctive type. So in Java, there is really like a way to actually create an interface, which is purely an interface. In C++, there is not. In C++, a interface is a special type of class, and the difference between a normal class and a interface and a class that contains pure virtual functions is explained quite easily. Like a normal class with no virtual functions or only implementing virtual functions, just a normal class like we have Sonnet. Last video we have discovered a new class, a pure virtual function, and so a pure virtual function, and so on, a class that can't be instantiated when objects can be created, which needs to be extended, which was for kind of like defining a class which wouldn't make sense to instantiate. And actually the interface is a similar class to that one, but the one big exception is that it has purely virtual functions, which means that an interface, it has no normal functions at all. An interface is just a header with a set of functions that are all virtual and all set to 0, or at some point maybe have an empty implementation, but in general they will probably be set to 0. Now the idea of the interface is that you kind of like define a contract on what an object can do. For example, if you have an interface runnable like Java, iRunnable in C++, you would define a virtual void run, and then you could run the function and things like that. So really the idea there is that you could like create an interface however you like it. You basically define a set of functions that's kind of like the interface of a certain behavior, and then you can add it to your class. And as I told you, we have multiple inheritance in C++, so we can add as many classes as we want in here. I don't know, did I told you that? But you could like add any other class. I mean, cat wouldn't make sense, but you could add here a public cat as another virtual inheritance here, and everything would be good. And since we have that scheme in C++, we can actually bring interface in here. In Java it was different. You just would have one base class and then would say which interface it's implementing, and interfaces could be 0 to whatever, how many you like, while you would just have one base class. In C++ this works differently, and this is gives you great flexibility, but this is also a drawback. We're gonna talk about this one later. I want to add a section today where we're gonna explain how I would recommend doing these hierarchies and what I would not recommend doing your hierarchies to keep your code clean and organized and to avoid further problems. But now let's get started about a interface. So what I want to do is I want to create an interface for interacting with a pet. So how I'm going to do this, first of all, I'm going to create a new file. As always, I'm going to create a header file, and I'm going to call this one interactable.hpp. Now you see that I've prefixed this with an I, and this I stands for interface, and it is something that I would really recommend. If you have an interface, always prefix it with I. So I interactable.hpp, create a file, write your class, or you could write your namespace here as well to be super safe pet manager, like that, and you write your class I interactable. Now, when you write an interface, you want to define a set of functions. So what I want to define is the interaction function. Now, how I'm going to do this one, the interaction function shall return a string, kind of like the result of the interaction. So I would need to include the string. I would say std string interact interact here, and interaction should not be constant. It probably should also not be no except. Now interaction should also get a parameter, but I want to interact with toys with the animals, so or the pets. So what I would need to do is I would also write a class toys so that I can interact with them. The toys are gonna be just simple structs. So not struct, let's just call this toy.hpp, and I'm just gonna put everything in here. Let me copy that one. And what I really want to do is I just gonna write this in here. These are gonna be empty structs. I want to have a struct toy, and based on its struct toy, I want to have a struct toy bone for the dog. There we go. Toy bone for the dog, which is actually a normal toy. And I want to have a struct toy mouse for the cat. And you could add parameters to them as well. For example, you could add something like float. Oh no, I'm an idiot. Durability, and by default the durability is set to 1, but since a dog might interact more than a cat with its toy, because dogs like to chew on them, while cats really, they just bite it most of the times, except if they are young. If they are young, they really are in the face of chewing on stuff as well, but let's maybe say this, the durability is to 1.5, but dogs are probably gonna be a bit more rough to their toys, or depending on what kind of dog you have, but in general, because they're also bigger, have bigger teeth and stuff like that. Could add some general parameters to the toy as well, something like the appeal, how much a toy appeals to an animal. So if you have a really fancy, nice, expensive toy, it's higher, and if it's like a cheap one, you can lower this. So yeah, you could use it, but these are really just dummy values that I'm just gonna abuse there. Alright, in interactable, I wanna actually include the toy, so let me include the toy.hpp. Actually, what I told you is that the syntax is to put the toy first, and then the string, and instead of the interact, I do wanna give it a toy reference toy for the interaction function. Now I told you that an interface is purely virtual, so we would need to mark this one as virtual to make it implementable, and then we're just gonna assign this to 0 to make sure it is assigned. Now you also need a virtual destructor, because it could be that we directly start with that, and if you're writing a class like that, actually, like, yeah, it might be that you want to put all of your classes as with a virtual destructor if they are the start of an inheritance chain, except if you can really say that they are not extended. Like really, what you should need to do as well here on the toy, if there are more complex types inside of the toy, you should also make a virtual destructor for the toy, actually. Because also structs, especially if you add types like std string, if you would add an std string to the toy, it would be really required to do this, because an std string does require explicit cleanup. If you have just trivial data types in here, it doesn't matter. But just out of good practice, you should always, if you're using virtual inheritance, you should always put a virtual destructor in there. Alright, so now you can see that our interactable, it's finished, and we are now ready to introduce this to our pets. Now, what you could do is you could put this into pet.hpp, but I don't want to add the interactable feature to all pets. I do not want to have that the pet is interactable by default. So the idea is actually that we only add this to pets that are like interactable. For example, with these toys here, a fish might not be interactable with a toy, or not in the classical way interactable with a toy. However, the fish is available or able to interact with water or with an aquarium or anything like that. And so what we just want to make sure is that we keep this a bit low, and we make sure that we don't get too fancy here and add this to the pet. And also I want to show you a bit of architecture of the C++ stuff. Alright, so now first let's add this to the pad. So I'm going to include pad, and I'm going to include I interactable. And to add the feature to the pad, I told you can do multiple inheritance, and I could do like a public I interactable. And now the pad is automatically interactable, but of course we need to implement the function, because if I would go to main, the tabby is no longer instantiable because the function is not implemented. Now, I don't know, is Visual Studio already bringing you some features to... No, Visual Studio does not allow you to automatically implement interfaces. There is something called Visual Assist. It's like an add-on for Visual Studio that gives more advanced features to your IntelliSense and the whole like Visual Studio systems, but I don't have this installed there. It also is not free, it costs money. Alright, so let's copy this over. STD string interact, override. And we can now interact with a toy. And what I want to do is I want to check if I can dynamic cast this one. So if I can dynamic cast this one to a toy mouse pointer, then everything is good. So let's make a pointer to the toy and see if I can cast this to a toy mouse. If this is the case, I'm going to return jump, because the cat jumps and tries to get the toy. If you are gonna give it any other toy, which is currently just a toy bone, the cat really doesn't know what to do with it, and it says looks confused. So if you give it any other toy than the mouse, the cat just looks confused, and yeah, it interacts with it. Now let's add the same feature to the, actually now you can see it works again, but now let's add the same feature to the dog. And for the dog, let's include I interactable, and I'm just gonna copy and paste everything from here to the dog. And what I want to do here is, of course we need to have the public I interactable here so that we can implement this one or override this one. And if it sees the mouse, it barks. And if it sees the toy bone, it sees the toy bone, it will chew on it. So it's now chewing on the toy, on a toy bone. It's, let's say, chewing. Because if we give it a bone, the dog is gonna chew on it. If we throw the toy mouse at it, it barks, and it looks confused if it's anything else, which we can't really interact right now. But you should always like have the option to have like a default reaction, because if you don't have a default reaction, it's a bit bad. You could also stripe this a bit down and put it in the default reaction like that to make this a bit, yeah, different, which is also totally fine. Alright, so now let's try to use the iInteractable. I'm going to go to main.cpp, and before we gonna do the sad story, we're gonna playing with our pets. Now we are playing with our pets. And the first thing that I want to do is I want to interact. Maybe let me first create the toys. So let's say the toy bone. And the toy mouse. And what I then want to do is I want to first interact with... No, we did so many cat stuff. Let's start with Oscar. Want to first play with Oscar, and after that we played so long with the cat that it got bored and died. Oh no, really, that's not the point. I'm again being a bit with black humor here, but yeah. Okay, so Tabby gets the bone. And the reaction to the bone for Tabby is Tabby interact with bone. That's gonna be the reaction of that interaction. And Tabby is, oh no, that's Oscar. So we should also interact with Oscar, not with Tabby. So first we're gonna put a bone, then we're gonna put the mouse to the Oscar. I'm gonna copy this a few times again. I'm gonna do this with the bone. Change that one to mouse, and I'm going to change that one to Tabby so that we have all the multiple versions of interactions that we could have. And we're gonna see how the pets are gonna react. Let's press F5 and see what's going on. And we can see playing with our pets. Why do we have a double new line there? Probably because Visual Studio screwed up again, but yeah. Oscar gets the bone and he's chewing. Oscar gets the mouse, he barks, and Tabby is also chewing and barking. Yeah, because we didn't properly replace the Tabby. Tabby is not a dog, so yeah. Oscar gets the bone, he's chewing, he barks for the mouse, and Tabby gets the bone and looks confused while she gets the mouse and jumps. So you can see that it works. It works and it's nice. And the nice thing is actually that we could now actually cast this one. We could say an eye interactable pointer pad eye or iPad. iPad like that, I mean, of course. And what you can do is you can store the Tabby in the iPad, or you could store the Oscar in the iPad, because both of them are interactable and they can interact with them. And the idea is that if you later on write a function where you can interact, so for example, let's say void interact with an I interactable in, a pad manager, I interactable reference inter to interact with it. You can see that you could, for example, if you would call interact, you could put in the Tabby to interact. You could put in the Oscar. You could cast to I interactable pointer, or actually reference II equals a Tabby, and you could also use an AI. You would, but if you would cast to a pet, pp equals Oscar, you would see that a pet can't be used with the interact function because a pet is not interactable. An interactable is interactable, Oscar and Tabby or cat and dog are interactable because they implement the function, but the plain pet, it's not interactable, so it would not work for the function. It needs to be a pet. You could also write a class interactable pet, which implements interactable and is based on pets, so something like that. Class interactable pet, public pet manager pet, public pet manager interactable, and then you could like say, for example, class red is a public interactable pet, and then the things would work as well. If you do it like that with like an intermediate class, even though if this intermediate class would be completely empty, to just bind like these two base classes together, you could then like based on the interactable pad, and everything would be good. You might need a bit of maintaining to put like constructor madness in here and stuff, but the idea is like, just because you're saying, okay, interactable is in here, you don't need to implement this one. It just means that at some point, starting with that chain, it needs to be implemented. So it worked as well. Now, do I want to do something more? Yeah, I do want to do something more, because our interactable is really a bad interface. The problem with our interactable interface is that it's not working how it should. Our interactable interface is currently just able to return a string and take a toy. However, you might have more interactable interfaces. You might want to interact with a fish, as I told you, with water, and it returns like a speed or something like that. Or like a medium. For example, in air, the fish is returning a speed of 0, and in water, it's returning a certain speed. So you might be able to interact with them in a whole different way. And also like the animals, you might want to add multiple ways of interacting with them. And yeah, for that we need to change this interface a bit. One important information, or one thing that we're going to limit ourselves today now, is actually return value, because it may give us some issues if we have different return values for the same function name, or for the same function name. This is why we're going to do this simple. And what we want to do is we want to be able to at least customize the parameters. The return value is going to be staying at the string, but the parameter should change to something meanable, and not just a static toy reference. Now, how can we do this? Well, we need to make this a template, right? If we make this a template, we can add arguments. So let's make it a template, type name, and the type name would be T. Now, if I would name the type name T, it's a bit bad, so what you could also do is you could just call this arg for argument, and what you can then do is you could replace it down here with the type of the argument. The parameter is called arg. However, this is actually not how I like it, because maybe you want to have multiple arguments for interacting with a pet. And this gives us to, or brings us to a new topic of variadic template arguments. Variadic template arguments are template arguments that can be used in a so-called variadic way, or in a way of having multiple types. So variadic template arguments means not just one type, it means multiple types, but stored as one template variable. And how are you going to do this? Well, you're going to add 3 dots. The 3 dots are indicating that this is variadic, and I'm also going to call this one args here. And what you would now need to do is, since this is variadic, you need to expand this, because args is now variadic, and it's really just a placeholder here for something that is a long list. And what you need to do is you need to expand this. In this case, it's done down here, because now you basically have this one. It's like the name, it's args, which is a variadic type name, and you want to also use it in a variadic way, so you add 3 dots here to get the arguments in there. Now, the only thing left to do is to actually use this now, because if I would now go to, actually we don't need the toy here anymore. If I would now, for example, go to the cat, you're gonna see that it's no longer possible to use this one, because we don't have the template argument list. Now, I could add some empty argument list. This would work, but this would also give us an issue, because now we would basically mean that our interaction function would take no parameter. So the interaction function would look like that. As you can see, if I would do this like that, it all works. Of course, it doesn't work in here, but it works with the template. If I add arguments, it doesn't work, because it's no longer matching how the template looks. Now, first of all, we need the toys now in here, because we want to use them, and then we need to specify what the arguments are. I could put in the toy in here, which you can see still doesn't work, because we actually have a toy reference. So if I add the toy reference, you can see the function works again, because now it's overwriting what the template, the interface is specifying, and the interface specifies as a parameter the toy. We could also add in another integer, which would again move this to not being able to implement this like that, but if I would add the integer here as a parameter to the interactable function, it would be good. What I now can also do, because our interface is way more flexible, is I could copy this again, and now just remove the integer and have the integer as an optional parameter. If I do this like that, I can actually have 2 implementations of my interact function. One with the integer, and one without the integer. And now you can see that I have 2 versions of my interact function. They both return an std string, but they have different arguments, because I have implemented 2 interfaces, and each interface is kind of like defining a different signature of that interface function. Now, it's important here that the actual functions interact, they all return the same return value. This is why I haven't changed this. If you have multiple versions of a function, they all need to return the same type. If you would want to change that, you could also add this as a parameter to the interactable. Maybe you should even add this to the interactable as a parameter, but you need to make sure if you use this multiple times that you're going to use it right. So what we can actually do is we could call this one return, just like that, just a return type, and instead of an std string, we should maybe put the return in here. And now it basically means that you have to define one return parameter and then 0 to as many as you want variadic template arguments. These variadic ones, 0 to infinity, or however you like them. Now on the cat, this is gonna now not work, but if we add an std string in here, you can see that they actually, oh, they both work. No, just that one works. That's what I expected, because the other one is really, it's not doing what it should do. Maybe let's format this a bit better so they can see what's going on there. If I would want to make both of them work, I would add that one here as well, which would make both of them exist. However, I do just want to stay at how we implement this, like that, just a single parameter that returns an std string, and now you can see this is looking good now. Now, of course, this needs to be done in the doc as well, because the doc is also based on the interactable. Now, let's also include the toys in here, toy.hpp. And let's add the signature, std string. And what we also want to add is the toy reference to use this one properly. What you could also do is you could alias it, so that's a bit better. So what you can do is using dog interaction equals to that. You can actually do something like that to kind of like alias this. This using is like, this is like the new name and this is like the actual type. And if you're doing something like that, you could write this like that, which looks a bit better. Dog interactions may be a bit bad. What I can do is rename this dog interactable. How did I write this? Interactable. I'm stupid when it comes to writing proper text. But as you can see, if I do this like that, it would also work. Or if you would even be a bit more explicit, you could say toy interactable. And if you would want to go total nuts with that and do this properly, what you could do is you could go to your, let me actually steal all of these. What you could do is you could go to your pet.hvp, and inside the pet, you could now include the toy.hvp and also the interactable.hvp. And what you could do inside of the pet manager, or actually maybe actually even inside of the pet, you could say using, but I think this using might not be accessible. We're gonna see this in a second because it's not public. Let's make this one public. I actually personally don't know if this one needs to be public or private, but I think it needs to be public, because if I would try to find the pet toy interactable, it would not find this. Yeah, it's not able to find this one. So you need to make that one. Where is my pet? Pet. I close the pet.hvp. There we go. You need to make this one public because this is dependent on the visibility. So if I make this a public using toy interactable equals interactable of std string and the toy reference, instead of the dog, this one should now be usable. So it's a pet, and it's also a pet toy interactable, so that the pet is interactable with a toy, which means that we don't need all that interface carnage here. We just basically say that the pet is toy interactable, and everything else down here comes in automatically. So you can see like this using is very simple. Here we just use the constructor. We pulled the constructor in with using. In the pet, we pulled in a new alias for the interactable interface with the proper parameters. So this is really powerful. The using is amazing in C++. It can do so many things, and it's highly recommended that you use it, that you are using it. Ha 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 ha, no pun intended. Ha ha. Okay, so now of course we want to do this with the cat as well, because you can see it's looking kind of like it's always a bit bad to include all of them, right? So yeah, interactable is not what we want. We want to have a public pet toy interactable. Come on, there we go. And everything still should come together. If I go to my main file, actually nothing should have changed, because we just did some wrangling with the interfaces. So yeah, that one is no longer working, because it's, we need template parameters. But what we can do again, you could also say, I want to have a reference to a toy interactable, and everything would be automatically, and it would be nice. So yeah. You can use this one as well here, and the syntax is just a bit better, so it's toy interactable pet. I mean, like, really, toy interactable is not really something that should be in the pet if you would be 100% precise, because it's not required that you are having a pet to be toy interactable. You could also have like a human who is toy interactable, a human that can chew on bones for the animals. But I just wanted to nest this into the pet so that you can see how you would use this if you nest this inside of the class pet. You could try to kind of like limit something to be toy interactable only if it's a pet, but that would be way too advanced, so we wouldn't do this. Could also, like, for a fish, you could do something like water interactable, which would get like a floating point of the speed of the water, or 2 floating point values for like. You could add some comments. Can I name them here? No, I can't. But what you can do is you can add a comment like that in between, and you could say something like water speed, and you could say something like No, it's just like that. Water speed and water depth. So really just some informations for interacting with the fish. So if it swims too low and it can't hold the pressure, it dies. If the water is too fast, it moves away. It gets new velocity and stuff like that. So you could really go and do many things with that. So templates and all of these things, they are so useful, especially when it comes to interfaces. I mean, they are kind of advanced, but yeah. I think, is that hard to understand? No, it's not hard. We have the return and you have the arguments, and you can put everything in here that you want, and it all comes together nicely. Just like a charm. Alright, so that's it for today's video. No, it's actually not for that video. Actually, we're gonna have a little section where I'm gonna talk about some guidelines that you should apply for your virtual inheritance. Alright, so now I want to talk a bit about rules when it comes to inheritance. This is an example of a good inheritance. So the idea here is in general that you have down there on the leaves of the tree of the inheritance, you have like your concrete classes, for example, a Maine Coon cat or a Norwegian forest cat or the fluffy dog. And fluffy just means, in case you don't know, Harry Potter 3 had a dog. And the idea here on a good hierarchy is that you have one root where everything is gonna go to. So the root of all of these three class implementations here is gonna be the cat. They have a way over a dog or maybe over a cat, and it's really like span out like a tree. But the thing is that the actual classes that we are using, they are always like the leaves of the tree. You're going to use a Maine Coon, you're going to use a Norwegian forest, you're going to use a fluffy, or you're going to use a dog, or you're going to use a cat. You're never going to start with the pet. It's always like from bottom to top in this case here. We are starting from the bottom. Maine Coon, it's a concrete implementation of a cat, which is a concrete implementation of a pet. And this is the idea how you want to build up your inheritance. There's one like root to which you're gonna go in a point. So this is like the one thing you're always gonna end up. You're always gonna end up with the pet. Or if you would have like cars, you would always end up on cars. Or if you have vehicles, you would always end up on vehicles. Or if you have machines, you would always end up on machines. And the vehicle is a machine, and the car is a vehicle, and then BMW is a car, and an Audi is a car. But it's never like that. An Audi is a vehicle, it's a machine, and it's everything within. It's always instead of this hierarchy, and it's always listed properly. This is how you want to have your general inheritance scheme. Now this is an example of a bad inheritance. You can see that's already swapped around. We are starting at the top with the fluffy, and you can see that the fluffy is a dog, the fluffy is a beast, and the fluffy is a magician. The dog itself is a pet, and the beast itself is an animal, and the magician is an NPC, which is again a character, and you're really gonna get into trouble if you have hierarchy like that. If you want to do something like that, like if you want to group many complex attributes together, you should not use the form of doing virtual inheritances, building like dependency trees with your classes. This is not a good idea. This couples the systems. These can bring you include and dependency problems, and that's not what you want to do. You don't want to do this like that. You can see that this error here is the other way around. The fluffy, which is a concrete implementation, is at the top, and the actual base classes are down at the bottom. Previously, we had it the other way around. We were going from bottom to top, and now we are going from top to bottom. This is where you can see that your inheritance lacks something. Your inheritance is always bad if it is the other way around than the general idea. The general idea is that you are starting at the root, and it goes out at the bottom, and the root is your base class, and at the bottom you have like your concrete implementations. While here the root is like the concrete implementation. There is even a worse example. For example, this example can really bring you technical issues, because if now the pet is a game object, the animal is a game object, and the character is a game object, you're really gonna have a hell of a lot of issues. Because we have like three game objects, and game objects where it has states, and now does the animal have the same game state or the same game object in the pet, because the animal might do different modifications to the game object than to the pet, which means that you need to have three different instances of the game object. But if you do a change to fluffy, which game object do you modify? And yeah, it's really not a good idea to do these type of dependency things. If you want to really do something like that, you should have like a doc behavior, a beast behavior, and a magician behavior, and you should composite them into the fluffy as parameters or as members. But that's a different kind of like architectural choice paradigm in software engineering, which we might get to in the future. But this is like something that we don't want to have. We don't want to have these deeply nested top to bottom hierarchies. And actually there is one exception that I want to show you, and this is on a specific course that I implemented but already deleted, but that's a different story, where you can break this. You can break these if you need to add multiple inheritance, multiple base classes to one class, where you can't help yourself of not doing it. An example here would be, for example, a script compiler that compiles Angel script code to binary, to bytecode. The idea is that the script compiler is based on a script extender class. The script extender class has access to like the scripting engine, the context, and everything that you need to kind of like extend your scripting. And the script extender is again based on object base. Object base is just a placeholder class. It's actually different in the project where I've implemented this, which was basically a base class which handles like ref counting, like automatically lifetime management of the object and more things in the future, which is kind of like a base class which you're meant to be implementing for every class that you do. So this is what like the object base is. You can see still the inheritance chain is very linear. You have the compiler, the extender, and the object base, so this is all good, but we have a problem here. Normally I would have flipped these and would say, all right, object base, script extender, script compiler, but you can see that we have another thing here in the chain. We have a C script builder, which is why this is also top to bottom, which I consider to be bad. However, this is an example where it's actually okay, because you can see that it inherits also from the C script builder. The C script builder is an add-on class of Angel script, which contains utility functions and also members that help you compile and reflect scripts. Now, what this really does is you call a function like add section from file, which basically opens up the file, reads all the content, and tries to compile the content, and then runs a reflection run over this. So what it's doing, Angel script with the C script builder, is it is kind of like filling its internal structures of the C script builder with the information on how the script is laid out. Now, normally you could just say, all right, let's use the C script builder as a parameter to the script compiler. However, the thing is that the C script builder does not expose all the properties that I want to access. And actually, I do want to access something that I have put inside of the C script builder, but it's not possible because it's not exposed. It is only exposed if you inherit from it and if you really need this, so that you do this. And this is why this is in this case allowed. If you do something like that, I haven't written that down, this is where you should probably privately inherit from that. So this is like the public path. This is the main path from the object base, script extender, script compiler. It's like script compiler is a public script extender, and the script extender is a public object base, while the script compiler in terms of the C script builder should be a script compiler and a private C script builder and a public extender, so that your main path is always going to be object-based extender compiler. So if you don't show all the private things, it still matches. However, if you are adding features like that because you need them, you have the script compiler, which is a private C script builder to internally access a script builder, but not expose it, not put it in the whole inheritance chain, but still be virtually in there. Now, normally you can see this paradigm because the inheritance chain here has only a depth of 1. It's just one single class that you inherit or one struct that you inherit. It is not like a whole big chain like we had here, like the beast, animal, game object, magic, and NPC character, game object. No, it's just a single one. This might not be true for all cases. There might be also base classes or also interfaces that the C script builder might implement, but this is something which is totally fine because it's, again, private and it does never get to the object base or the script extender. Really, the C script builder is an external component, and the external component was composed and might have hierarchy based on classes of the external library as well, but it's just one single logical concept that you build on. If you're writing your code, you know that the script extender is an object base and you're intending to use the object base and the script extender, while in this case you're just intending to get access to the C script builder in a way so that you can modify it. And yeah, you should really try to minimize these use cases as well, but this is like an exception where you can break the rule. While that one is bad, architecture of your application. This one is something that you never use. That one is something that you can tolerate. You can see this one is simple. It's simple to understand. This one is just a mess. We have actually one more exception, which is not really an exception, and it's the interaction with interfaces. Interfaces are a thing that I would never include in these diagrams. However, if you would put them through a software that generates these diagrams automatically, it would include the interfaces. However, interfaces are a certain special kind of functions, which is why I do like to treat them differently. Now, again, you can see the structure that we are going bottom to top. We have the Maine Coon, the Norwegian Forest, and the Fluffy again, so the first example. And what you can see is that the inheritance is still the same, and the only difference is that we have like these bars around them, and each level implements interfaces. And this is something that I would normally do. It's not holding up completely true, because actually the Fluffy was going to implement different interfaces than the cats, and so in this case, really what I would have needed to do is I would have needed to break this one up here and make 2 of these bars, but Microsoft does not like to do this, and I'm not gonna spend too much time in creating diagrams here. So really the idea here is that you have the pet, and the pet implements the interface iPetable, because you can pet a pet, right? If you pet a fish, it might react badly on it, but you could try it. Right? But the idea is that you have like the pet here. Then you have the interactable with a toy, which you can do for a cat and a dog, for example. You would have the interactable on music, which you can do, for example, with a Fluffy. Or you would have the showable, where you can show off your breeded cats, your, like, I don't know how this is called, but in German it's like reinrassig, but it's also a bit, I don't like to say this in English to not be called a racist, but if it's an animal, you can still talk about race. I don't know. I haven't talked about animals, and like in Germany, we have like these actual shows where you go with your pets and you show them off. And these shows are just for the like pure race dogs, pure race cats, or nearly pure race dogs and pure race cats, where you show off the important features of the race. And yeah, you would have like this showable on pure race cats, for example, Maine Coon and the Norwegian Forest. It's like pure race cat, it's like it's an own class, and so it has the showable, while if you have like a non-pure race cat, it's just gonna be an implementation of a cat, and it's not showable because it's not a pure race. And if you like breed 2 cats and they are both showable and they are both the same showable, they still gonna be returning a Maine Coon cat, but if they are different, they just return a cat and stuff like that. You could implement some serious business logic in there here as well, but like the idea here is that you can just see that these interfaces are not really something that I would put in these inheritance trees, because interfaces are actually that one. An interface is actually just one hierarchy level that adds features to this. There are no like base classes, there are no members, there's nothing in here, no dependency that you put in with an interface. It's just the set of functions that you implement. And that's totally fine. Now, of course, in interfaces, you also need to be a bit concerned that you don't add the iPadable again to the Maine Coon, because it's already in there with the pad, and it would be bad design to add the iPadable in there as well, even though C++ might not even complain to you that you put an iPadable in here, but you already have it from the pad, so it would be a bad architecture that is in. But basically what I like to do is I like to do these diagrams like that, and I always like to keep my inheritance actually simple. Normally what I would have done, I would have done 2 diagrams, one for dogs and one for cats, so that I can show this off. Or if you would have like dogs and cats and they are all the same without the Fluffy, but also like dog races, then I would have had the same diagram with dogs, and there's an example for dog races, and then probably a few more boxes with ... so that you can see how it goes on. This is just how I like to put all this together, and I would advise you to do this as well. So let's go quickly back to revisit this. In general, this is the hierarchy that you want. You want to have at the bottom the leaves of the tree. You want to have the most concrete implementation, like the races, Maine Coon, Norwegian Forest, or the Fluffy 3-headed dog. And at the top, you're going to have the most basic interface, which is in this case the pet that we are looking at. You never want to have inheritance like that, so that you have the base interfaces down, or the base classes down there, like the pet, animal, or character, and then have multiple inheritance up to the Fluffy, which is going to make things more complicated, adds issues to that, especially if you have then one shared base class that each of these classes implement, like in this case a game object, which just can produce very bad things, and you're going to have behavior that you can't understand. It's deterministic. The C++ language will do it or will at least try to do it properly. I don't know really how it's gonna work out, but it's gonna give you issues. This is something that you're never gonna do. I personally not do this at all because it does screw you up, and you don't want to do this. On the other hand, interface is totally fine. You can add interfaces on each level of the hierarchy because of that rule that we had here, that you can have one if you really need it. But again, you should avoid this, right? If you have an interface that you can put to the base class, you should always put this as most to the base as possible. You can also have interfaces which do not need a implementation. We haven't done this in code, but the idea wouldn't be... Okay, no, I'm on a different screen. Can I get this one up here quickly so that I can show this to you? So really what you can do here, for example, if you, for the interactable, if you don't want to do this here with 0, what you could do is you could add a default implementation here, and what you could do is you could return here, which basically calls the default constructor of the return value, and it would automatically add an implementation for that you don't really need to implement. This would be fine for an interface even through, or I would say that this is fine for the interface. However, different people say no, an interface should always be pure virtual. It's again a question of philosophy. How do you like your style of software engineering? I think it's fine, but yeah. No, don't go further. Okay, so thank you for watching. I hope you enjoyed. If you enjoyed, make sure to like and subscribe. And I wish you a nice day. See you in the next one. Bye.